All right, it's going to be fun. Let's go to number one. So in number one, we're looking at web server attacks. So what are you doing right now? Oh, you're in a class. And where is this class? It's online, isn't it? It's being served through a web server. Now, every once in a while in this class, I'll ask you to open up a tab and go to Google or DuckDuckGo. Where is Google or DuckDuckGo? Where is that page coming from? A web server, you say? Absolutely, it's coming from a web server. If I ask you to go look at RFC 1918 from the IETF, and you go look at that page with all that small print, where is that page coming from? You guessed it, a web server served out of a virtual machine or a container. Either way, the web server is serving the web app very often, and that is what we see day in and day out. A lot of organizations have their own web applications running on their own web servers, which really need to be protected. So let's get started talking about web server attacks. So let's talk about various web server attacks. A few things we need to think about when we are talking about web servers and really their functionality. So here's the web server. There's a web container. There are services. There is a data store for various applications that might be running associated with that web server. There are requests and response that are made through servlets on the web server to the web application server. And there is a static store for information that's usually on a hard drive SSD or on an attached service for a storage, network attached storage server. But then on a phone or on a tablet or on a desktop or somewhere, there's a web client that makes the requests. HTTP request comes back. The web server checks with the servlet, makes a request to the application server and the static data store and the application data store. Together, they put together a page and the client downloads it and runs it. This is just a typical way web server operations work. And there are many different components. And when you think of a web server that runs many different web applications, remember, it's just a computer. For the most part, it's just a computer. And so it has folders and it has files, and out of those folders, and one of those folders, guess what? Inside one of those folders is a document store that has, for instance, the default HTML document that loads when you go to that URL, that universal resource locator record, like www.somewebsite.com, right? And so that document root is part of the server root that has configuration files, documents, executables, log files, etc. And there is an entire virtual document tree on the machine, on the disk, and so we want to make sure that we manage that if you're managing web servers. Then we may have a proxy that sits between the client and the web server that helps with some security, prevent IP blocking, help to maintain anonymity. And then we have virtual hosting. This is a technique that you'll find on most web servers where I can host multiple domains. So if I go to GoDaddy.com and I buy a domain called KevinKingDomain1.com, and I buy another one, KevinKingDomain2.com, and Kevin King Domain, I buy 16 domains, and I want to put out 16 websites on my web server, I can virtually host each of those domains and have a separate website and a separate storage and so on for the virtual document tree for all of those Kevin King domains that I just purchased at GoDaddy. So those are some of the components that you'll find in a web server. Now, here's one of the major issues. One of the major problems is way down here, we have security. We have a lot to think about right here at level 1. We have firewalls, intrusion detection systems, intrusion prevention system. We have host-based intrusion detection system and prevention systems. We have wireless intrusion detection and prevention systems. We have a lot of stuff going on right down here at this level. But wait, there's more. We also have the level above that in stack 2. We have routers. In fact, there may be 15 or 16 routers in a medium-sized organization. There may be 50 to 60 switches in a medium-sized to larger organization, and each of them have VLANs and routing protocols and router security and VLAN security, and they may have redundant architectures, and they may have secure protocols, and they need to be hardened, and so on, and more right here at stack 2. But wait, there's more, because at stack 3, we have Windows and Linux. And so we have Windows workstations running Windows 10, Windows 11, Windows servers, running Windows Server 2016, Server 2019, Server 2022, Linux. We have Ubuntu, we have SE Linux, we have Mac operating systems in one of our graphic design department with 20 people working on Macs, and each of those has to be hardened, looking for every service, every protocol that should and shouldn't be running, every application, updating every application, updating the firmware on the servers that have drive controllers and drive arrays, and it goes on and on. All of that is right here at the operating system stack. But wait, there's more. You might have MySQL or Microsoft SQL Server, SQL Server, Oracle, and other databases serving various functions. Those have to be updated, maintained, secured. You might want to use data masking on your database. You might want to use encryption on your database transactions. You have DBAs and DBOs that administer and own the database, and a lot of work to be done at the database level. And then finally, right up here at stack 5, there we have our web server that needs to be secured, that this module is going to be talking about, Apache, Nginx, Microsoft IIS. And guess what? There has to be in all of these stacks up to stack 5 is one flaw, one hole in the security, and an attacker has a foothold on your system. But yet, you, as the network defender, the ethical hacker, have to lock down tens of thousands of combinations of protocols, ports, programs, applications, devices, etc. You have to lock it all down and keep track of it and make sure that it is secure. So that is the security issue. It is the complexity of the different stacks put together as a whole that really gives you a lot of work to do. And that's why at the beginning of this class, if I didn't say it, we need you. We need you working in the security field to help keep all these levels secure and trap and prosecute and stop attacks. So the impact of web attacks: accounts can be compromised. Websites can be defaced. Root access to the server can be obtained, exposing other applications and the operating system of the server. Data can be tampered with and stolen, causing not just the attack on the website, but they can bounce from that web server into the interior of the network, into the DMZ, into the data center, wreaking havoc wherever the attacker goes. And if they have enough of an attack, a big enough attack, then there can be reputational damage to the company. Did you hear about XYZ Corp? Yeah, they were attacked. I can't believe it. I don't know if I should buy anything from them again. So lots of impact for web server attacks. Why are they compromised? There are many reasons. Let's look at some of them. Number one is there are improper file and directory permissions. So let's say that I ask you tomorrow, I say, you know what I'd like you to do is I need you to build me a web server and so I can build a website. And you might say to me, but I've really never worked with a web server before. I'm not sure what to do. And I might tell you, hey, you know what? Just go to YouTube and find yourself a 15-minute video on Apache. All right, let's see if we can get done by tomorrow. Yeah, tomorrow morning. And so you watch a 15-minute video on Apache. You discover, oh, Apache is a web server. Oh, these are some of the commands that you use to install the web services. And in another hour, you have a web server up and running. Well, now, maybe tomorrow, for instance, I upload my website and my website starts running. It's posted on the internet for all to see. However, there were some configuration setting problems. There were default settings. Nobody changed the file permissions. Why? Because maybe you didn't know about it. Maybe this is your first web server ever. Who knew that you're supposed to secure files in a certain way? Maybe on the web server, there are still services running. Do you know that on a lot of these web servers and a lot of databases, there is an example site? It's like a test example site just to show that the web services are running. Maybe you left the sample site there. So those are some of the issues that could happen. And maybe there's no integrated authentication with back-end systems like Active Directory or something. Maybe it's a standalone web server. Maybe there's a default account to Apache or whatever web server you're using. And so overall, a web server can be misconfigured. Right now, were you to ask me the same thing? Hey, Kevin, can you do me a favor? Can you set up a web server for me? I know it's kind of late, but I really need to post a website tonight. I probably wouldn't do that good of a job. I would have to come back later and run tools to look for vulnerabilities and then get guidance as to how I should lock it down, right? It's not something you know unless you do this for a living. So there could be conflicts with business cases. There could be maybe a lack of security policy. For instance, if an organization had a strong security policy and they wanted me to set up their web server, guess what else they would have? They would have a standard operating procedure for setting up web services for the organization, and I could follow the procedures and lock it down right out of the box and just go page by page and set up the web server and make it super secure because there was a procedure, because there was a policy. So that becomes something very important too. I would love it if I could set up a web server according to a policy with a standard procedure that I could follow step by step. It would make me feel confident that I'm doing a pretty good job setting up this web server. So each one of these are possible reasons why web servers are compromised. And there are many different types of attacks too. Let's talk about attacking web servers. One of the attacks is a DNS server hijacking attack. And in this case, what's going to happen is the attacker is going to compromise DNS servers, change their settings. With that done, when a user has a FQDN, fully qualified domain name, or a website URL that contains the FQDN and so on, request the DNS server, hey, DNS server, can you give me the IP address for Kevin King's new website.com? And it'll send that to the web server. And the DNS server checks its mapping for that. It checks its database, sends it back to the user. But oh no, that's not real. That's been compromised by, this person, they're wearing a hoodie. I should have known. They're wearing a hoodie. And it's been compromised. And instead, I get sent to the fake website. You know what? These fake websites, they look very real until you get too deep. And then they start to fade from the reality. But they are surely good enough to collect credentials. So that is one. DNS server hijacking is one web attack. Another web server attack is a DNS amplification, taking advantage of how DNS servers can do iterative queries where they recurse through the entire DNS hierarchy. And what we do as the attacker is redirect them to perform an amplification attack. So let's look and see how that works. Number one, the user needs the IP address for a URL or an FQDN, fully qualified domain name. And it says, hey, what's the IP address to this FQDN, certifiedhacker.com? Please reply to my IP address, is what the user's PC is effectively saying. Sends that over to the user's primary DNS server. And with this DNS server, a recursion is allowed, which means that the server is allowed to make what's called an iterative query. See, this is a recursive query right here where the user says, hey, give me an answer. That's a recursive query. But an iterative query allows the DNS server to rebuild the FQDN from the TLDs on up. What in the world does that mean? Rebuild the FQDN from the TLDs on up. So TLD is a top-level domain, like com. So for instance, what will happen is it's never heard of this, so it will contact one of the root servers of the internet. There are 13 root servers that are spread all over the world, many different versions of each of those servers. And so what it'll ask is one of the root servers, where can I find the address? And it'll ask for a .com namespace that's nearby that might have the address. And then from there, it finds another DNS server that is responsible for the .com, that's a TLD top-level domain, .net top-level domain, .mil top-level domain, .cc, .gov, or whatever. Those are top-level domains. So it gets that TLD information, and then it says, hey, do you have the IP address to certified hacker in your database? And the .com server says, yes, I certainly do have the IP address for certifiedhacker.com. So that entire escapade through all the levels of the FQDN of the name that needed to be resolved from the TLD all the way up, that is what we call an iterative lookup. And at the end of the recursion, the DNS server provides an answer. Now, this DNS server, if it didn't have the ability to do recursion, it could have just found another DNS server and say, hey, I can't look that up. Hey, a secondary DNS server, do you have the answer? And if that had happened, then it would have been a non-authoritative answer provided to this user. But in this case, it did all the work, so it's authoritative. But here's the problem. Because of the ability of this DNS server to look at the entire domain tree and find the IP address of one of these sites, because recursion is turned on, there is an attack that can happen. So here's what happens. So the attacker, what they're going to do is use a compromised PC that has a spoofed IP address. In the end, what they're going to end up doing is amplifying a distributed denial of service attack against their target, against the PC. So they're going to send a signal and say, activate bots. And the bots are going to all turn on and get activated inside all of the PCs that people are owning and using all across the country and other places in the world. And here is how it works. The botnets are going to say, what is the IP address for this? And they're going to say, reply. Don't reply to the botnet computer. No. Reply to the computer that we are attacking. So can you imagine it's going through all the recursion, grabbing all the IP address information, and then when the DNS server finally replies, what it does is it replies using thousands of requests to a single address, amplifying the attack, right? So that's because on this DNS server, recursion is allowed, and this server is not authoritative for certifiedhacker.com. And as part of all that, it sends the attack to one device. Other types of attacks, and this is one I've used very successfully before in capture the flag contests and so on. And this is a directory traversal attack. So when you look at where a web server is, it's just a file. It's just a server that has folders and files in it. And the website or the web app itself is just stored in folders on a drive somewhere. And so if my web information, let's say it's in webroot, and I type in .. it takes me up to inetpub. I type in .. again, it takes me up to the C drive. So I can do .. combinations and a trial and error method. In fact, I can even, like if I'm on a Linux server, I can type in etsy.passwd and get into some password information and try this over and over again until I get to where I want to go. And then from there, I can read information, execute code, stuff like that, if it's possible. The next attack is website defacement. Many websites get defaced, and what they do is they just alter the appearance. They can say, you've been pwned, you're hacked, or they could put all kinds of curse words or really gnarly pictures on the website and stuff like that. Or maybe even just put a bunch of propaganda on the site, political propaganda, religious propaganda, propaganda on the site. That's defacing the website. The next type of attack is really something that happens because the person who's working with the web server misconfigures it. It's a weak configuration of the web server. It's just not configured properly. Here are some configuration problems. Let's look over here. So remote administration on the right side, we see allows somebody to get into the web server and remotely administer it. If that's not secure, if information leaks from that connection, then that can be a big issue, allowing an attacker to remotely gain access to the web server, unnecessary enabled services. So you may have a web server that's running on a device that has many other things that it's doing that are unnecessary for web services. Is Microsoft Office necessary to run a web server? No. Is Adobe PDF Reader necessary to run a web server? Is some music player or other type of software? These are not necessary for a web server. What we want for the web server is only necessary files. And we can have certificate problems that are misconfigured. They could be old versions, stuff like that, the attacker can look at the handshake for SSL and determine that it's old and start an attack. Here's another problem too. Let's say that I go to a web server. There's a website on the web server, and I open up the website and there's an error, and it says error 501, and it gives me all kinds of information. Error 505 or 404, and it gives me all kinds of information. Attackers use that information to do more attacks. And so what you need is generic errors. Maybe you've seen this before. You go to a website and it says, oops, an error occurred, and that's all it says, right? That hides that error reporting information from the attacker, and so they can't use it for further attacks. Another one is anonymous or default users or anonymous or default passwords, which can be left over from a bad install where you forget to remove some of the defaults. Another one is sample configuration files and script files. Like I was saying, a lot of web servers come with a default website to kind of demonstrate what the web server looks and show you that the web service is actually running. Same with scripts and so on. And we need to make sure that if they're not needed, they're removed. And really no sample is actually needed for a production web server. Also, we have other misconfigurations. Here are a couple of examples. And here's one where anyone can view the server status page that has detailed information about the web server. Look at that. You can see, you can't see much, but this is the httpd.conf file on an Apache server, and you can dump all kinds of information about the web server using that. Here's another example. This one gives you TMI, too much information, in this php.ini file, where the attacker can go look and see information on errors, syslog entries, and other information that are because of verbose error messages. That's another issue. In terms of web server attacks, another one that's pretty bad is an HTTP response splitting attack. With this one, what happens is there is a header that's added to the response data. And so you could use something like Burp Suite and edit the response data, adding in a header, and that splits the response data into two fields so that the server splits the response into two responses. So we get two separate responses. And so the attacker controls the first response. And what they do with that is they redirect the user to a malicious website rather than where they are going to go. This is a response splitting attack that happens. In this case, it's Jason the hacker that's sending the user to the improper website. Another one is web cache poisoning. Web cache poisoning. Whenever you hear the term poisoning, that means that we are taking legitimate entries into some type of cache and we are changing them. So where do we have caching? We have ARP caches. Talked about that a little bit, where ARP entries are cached, and you can do ARP-A and look at them. We have DNS caches, where DNS lookups are cached, and you can use NS lookup, for instance, on Microsoft systems to look at the DNS cache. And we also have web cache. What your system does is takes the website that you looked at, and in reality, guess what you did? You downloaded that website. And since you downloaded the website, it's cached on your computer. But what an attacker can do is poison the web cache. And in this case, what they're going to do is use a multi-step process to swap out the cache content. And so if my web cache has been poisoned, swapped out, instead of true and secure content, when I go back to that URL, I'll be redirected to a fake page where all kinds of bad stuff can happen. So in this case, this attacker is flushing out my actual cache, putting in their own information with a specially crafted request that will take me where I don't want to go. That is a web cache poisoning attack. Here's another one called a SSH brute force attack. Whenever you hear the term brute force, what you do is you're going to try every possible combination until you find a combination that will break or attack or crack whatever it is you're attacking. That's what a brute force is. And so what we're doing in this case is we have SSH. You think, wow, SSH is nice. It's secure. It makes everything encrypted. But if you're using the wrong version, or if it's implemented improperly, it can make your network not secure. And so what they do is they brute force the login credentials of a bad version or install of SSH, and they get unauthorized access to the SSH tunnel. And so meanwhile, while I think, wow, everything is secure, at HTTPS, realize that the attacker is able to run exploit, transmit malware, and do other types of pretty bad stuff because SSH has been compromised in a brute force attack. Another type of attack is a web server password cracking attack. So what happens is there's a weakness that allows the web server to attack the passwords, an attacker to attack the passwords of a web server. And so some of the most common passwords that somebody might find in a web server are simple: root, password, administrator, admin, and even demo or test. And can you imagine QWERTY, guest, what's a pet name? Fido, Dogface, I don't know, all kinds of pet names or whatever it is. Look up the top 1,000 passwords, and those might be some common passwords that might be found in a web server. And so what the attacker does is targets things like SMTP services, web servers, like we saw before, SSH tunnels, web authentication forms, cracking those. And if there's an FTP server, those can be very crackable, and they can use many different ways to get these passwords. Sometimes it's impossible to grab the password from the web service stack, so you just ask somebody, social engineering, or do some spoofing or phishing, or maybe even upload some malware like a virus or whatever. Still doesn't work? Well, maybe we can do some wiretapping and listen in on what people are saying, or sneak into that company carrying a ladder with a uniform on and make it all the way back to the system administrator's workstation and plant a keylogger and just wait till I collect all the passwords from the keylogger. There's so many different ways that an attacker can crack a web server password. So one of the ways that they can do that, this is going to be an attack that we're going to use a dictionary attack, right? And so this is actually THC Hydra. Let's have a look in and see what this hoodie clad attacker is doing. What they're doing is in Parrot Security Linux, they're typing in the term Hydra. Oh, no, this is not the one in World War II with the guy with the red face and so on. This is a whole different Hydra. This is THC Hydra, and we do a -L for list. And then we do a /ROO, and we hit tab. In your lab, when you're doing this in your lab, you do that /, type ROO, and then hit your tab key, and it fills it into you for the next slash. And then you type in W, tab, and it fills in word list / for you. You type in U, capital U. Remember, you do capital W for word list. Remember, Linux is case sensitive. And if you use that tab key, it'll fill in each leg of this path for you. And then you put a space there, and then a --P for passwords. You put a space there, type in /ROO, and then hit tab. It fills it into the next slash. And then you put a capital W tab, and it fills that in. Capital PA tab, and it fills that in. And then, so now what we've done is we have a list of usernames. And we have a list of passwords. And then we put a space in. And then we have the target of the attack. We're going to attack an FTP server. The FTP : / to give it the 10.10.10.10 IP address, hit enter, and then listen to the music play as the hacking commences using that word list. And then, oh, we found one. Look at Apple is one of the passwords. Username Martin. Oh, wait, there's two more. Jason is another username, password Courtney. Oh, look at that. Sheila is yet another one with a password of test. So in the real world, it's not so easy as the demo you have from your lab. Like for instance, there was a capture the flag contest, and I needed a password list. And there are so many word lists out there that are so huge that I finally found a username and a password list, and it was 84,000 something, around up to 85,000 entries. And it ran for a day and a half, and I got 0 hits on the username or the password. So in the real world, it's not always as easy, but in your lab, we want to make sure you're successful and you know how the tools are used and how they work. And so we help you out by giving you usernames.txt and giving you passwords.txt with nice, simple stuff to crack, like Apple, QWERTY, and tests. Another type of web attack is a server-side request forgery attack. One of the things you want to keep in mind with the word forgery. Forgery indicates, foretells the fact that in this attack, there was a login. All right. So what happens with a request forgery is there's a public web server that gets a crafted request from the attacker. What happens with the user, which you don't see on this page right now, but the user logs in using some type of credential. Either way, the web server sends a request on behalf of the user, and then data gets responded by the web server. But what happens in the end is if the attack is successful, they can do all kinds of activities on this network, on the server, port scanning, IP address discovery, reading files, etc. So they have a public web server. They send crafted requests to that backend server, and using SSRF, they are breaking in to that service.